Hello dear students, this is Mallikarjun, one of the senior faculty in physics. Now today onwards, I am going to continue mechanics part from first PUC in NEET level. So anyhow, I know maybe Newton laws of motion are started from that Newton laws. So maybe I need to start friction. So I hope friction also some basics are over, but let me continue friction from zero level again. Okay, so in this session, let me continue the friction basics, and based on the time and situation, let me continue some basic level of problems. Okay, and I am going after that. I am going to cover some plenty of concepts related to friction and laws of motion, everything. So write down the chapter name. It's not the chapter actually. It is a subtopic from laws of motion. So write down friction. See, in laws of motion, there are two parts. One is Newton laws, like you know, first law, second law, and third law, and another part is friction concept. So far you know Newton first law and second law and third law. See, in the third law, everyone remembered, I think, for every action there is an equal and opposite reaction. Okay, that you know that. And you know that action and reaction will act on same body. Is the action and reaction will act on same body? For example,
Two different bodies, sir.
yeah, for example, I am standing on a floor. Then what I am doing now? I am exerting a force on floor. At the same time, floor exerting a opposite force on me. Of course, they are equal. They are equal, but where they are acting? They are always acting on two different bodies. So action, if it is on floor, reaction is on me, by the floor, okay. In the same way, if any two bodies which are in contact, if any two bodies, for suppose I am going to place a block on horizontal surface. So let us suppose I am going to place a block on horizontal surface. See, this is the block whose mass is m, placed on horizontal surface. Then in between this, there will be a contact force. I think you hear the name contact force. This contact force will be there in between two surfaces which are in touch with each other, which are in contact with each other. And see, there are two different types of contact forces. There are two different types of contact forces. Let us see what are the two different types. One contact force acts perpendicular to the contact surface. See, this is the contact surface. One contact force acts always perpendicular to the contact surface. So that force we can call it as normal reaction force. What is that force? Normal reaction force. So normal reaction force is the force which always acts perpendicular to the contact surface. So normal reaction is the force which always acts perpendicular to the contact surfaces. Okay, this is the normal reaction force, and it acts perpendicular to this contact surface. And one more force is acting parallel to the contact surface. One more force is acting parallel to the contact surface. This is the part parallel. This force we can call it as frictional force. So one more force is acting parallel to the contact surface. What is the name of that force? Frictional force. One is perpendicular to the contact surface, nothing but normal reaction force. Another one is parallel to the contact surface, call it as frictional force. See, our intention is to learn what is the exact meaning of friction, in what direction the frictional force will act. So in this session, I am going to cover some basics. Next, maybe some problems will come based on the time and situation. Here, let us see what is the friction and what direction the frictional force will act. Okay. See, this is a block which is placed on horizontal surface, and the frictional force will act in between two parallel surfaces. Or for suppose, just imagine a body which is moving on horizontal floor, a car moving on horizontal floor. See, this is the car moving on horizontal floor. And see, if the engine of the car is switched off, then what is the motion of the car? No doubt the car will decelerate, and finally, after traveling some distance, the car will comes to rest. Yeah. Here, whenever the engine of the car is switched off, some opposite force acting on the car. No doubt that opposite force acts in between the two surfaces which are in contact. And see, some opposite force is acting here, in between where? Tire and the road. And this opposite force, we can call it as frictional force. This opposite force acts in between two surfaces. Which act in between the two surfaces, we can call it as what? Frictional force. Or the phenomenon, we can say that friction. So what exact meaning of friction means? It is the force, friction is the force which always opposes the relative motion in between two surfaces which are in contact. So what is the friction? The force which always opposes the relative motion in between two surfaces which are in contact, call it as a frictional force, or we can say that friction. Okay, so friction opposes the relative motion. Okay, relative motion. Why it is called as relative motion means the two surfaces are in contact. If there is no contact, there is no frictional force. Okay, here, see, this is the frictional force, and there are some advantages of friction, and there are some disadvantages of friction. So very basically, we know I am walking on a floor. How it is possible? Because there is a friction in between my feet and floor, so that I can walk. So just let us see few advantages. Very basic things. These are advantages. Okay, general things. These are actually. See, I am walking on a floor. Because of what? There will be a frictional force between me and floor, feet and floor. So we can write. So the safe walking on a floor is possible. Safe walking on a floor is possible because of friction between floor and feet. So this is one of the advantage. Of course, I am exerting some force on floor. Floor also exerting some force on me. That is no doubt in different directions and on different bodies. One is on me, other one is on floor. See, safe walking on the floor is possible because of friction between floor and feet. Okay, and in the same way, we can drive the screws and some nails into the wall so that the screws will tight fixedly. How it will tight fixedly means because of what? Friction between the nail and the wall. So the board I can place on a wall, and I can fix this board onto the wall by using some screw nut bolt. You can drive that nut bolts into the walls so that nut bolts will fix the board tightly because of what means frictions. In a simple way, we can say that nails and screws are driven. Nails and screws are driven into the walls and wooden board, driven into the walls and wooden boards because of what? Because of frictions. Okay, so nails, screws we can drive into the wall because of friction. Okay, and see, because of friction, if you apply the brakes of a moving vehicle, then vehicle will comes to rest or not? Yeah, if you apply the brakes for a moving vehicle, then vehicle will comes to rest. Okay, so by use, because of the friction, we can stop the motion of vehicles by applying brakes only. Because of friction, we can stop the motion of vehicles. Okay, and see these are some few advantages, and there are very few disadvantages also there. Okay, very few disadvantages also there. Okay, basic things I'm covering now, very basic things. Okay, see, for suppose if the vehicle, a new vehicle which is moving on a floor, which is moving on a road, and see the lifetime of the tires of a vehicle after some time. What about the shape and size of the tire after some days? The shape of the tire will be same or changes? No
Change,
doubt.
sir.
Yeah, it will change.
Reduce, sir.
Okay. Yeah. Here the shape of the tires changes means that wear and tear of the machinery parts will increases. The wear and tear shape out. Okay. So if you purchase a new car after 1 year, the tire shape is different. Okay, the tires are changes. The shape of the tire is changes. So we can say that the wear and tear of machinery parts increases. So this is one of the laws. Machinery parts increases. The wear and tear of machinery parts increases. And see the engines. For suppose if any engine, any electrical engine, any motor is running from morning to evening, okay, if the engine runs continuously, then what you are going to observe? You are going to observe some heat energy coming from the engine. Okay, so it will emit some heat. The engines are heated up. If it runs continuously, the engines are heated up. Okay, it loses some amount of heat energy. That is also the loss. Okay, maybe the lifetime of the engine will be decreases if it continuously running. So the lifetime of the engines are decreases. So this is also one of the disadvantage. The lifetime of the engine will be reduces because of the friction. Of course, there is some piston arrangement, and because of all, if the engine runs continuously, maybe the engine parts are heated, so that it will emit amount of heat energy, and that is also the loss. Okay, the lifetime of the engine decreases because of friction. Okay, and see the strength, lifetime strength, almost same meaning. Efficiency of the engine also. Tell me, is it decreases or increases? Efficiency, nothing but the strength. Efficiency,
Decrease.
yeah, power
Decrease.
efficiency, because you know efficiency nothing but a output power by input power. So efficiency of the engine is decreases because of friction. Efficiency of the engine is decreases because of friction. Okay, so these are very few advantages, general things these are. Okay, and see, there are some methods. We cannot eliminate the friction permanently. We cannot eliminate friction is zero, because if you touch any surface, then that surface is little bit rough, because we cannot get a smooth surface. Perfectly smooth surface is nothing but an ideal concept. Perfectly smooth surface impossible to get. No surface is a perfectly smooth. Every surface, if you touch, something friction will be there, something rough. And see, the main cause for the friction is, for suppose if I place this duster on one more duster, then to move this duster on one more duster, definitely you need to apply some force on it. Yeah, we need to apply some force on it. Why? Because in between these two dusters, you feel that downside also one duster is there. Okay, you feel that one duster is placed over the other duster. If I apply a force on this, it will never move. Based on the application of force, may it move. Okay, just after see I'm applying a force, will it move? No. That means what? In between them, what is there? Some friction is there. In between them, some friction is there. Okay. And see, if you observe this thing with a powerful microscope, then there will be an interlocking in between the two particles. Particle, for example, if you observe this from a microscope, a powerful microscope, if you view from the powerful microscope, one body will be interact like this. Okay, here there will be a roughness. Because of that, there will be a friction. Okay, so here one means the one layer will be interlocking the other layer. One layer of the first one is interlocking with the other layer, so that there will be a friction in between them. Okay, and see the surface are said to be easy to smooth. No, that is a rough surface. And see, we cannot eliminate friction permanently, but we can reduce the friction to some extent. Okay, impossible to get the zero friction, but we can reduce the friction to some extent by using some methods. Let us see what are the methods. So methods to reduce the frictions. So very basic things, these are methods to reduce friction. Methods to reduce frictions. So this is also basic question and basic thing. See, there are 4 methods to reduce the friction. One is polishing. So by polishing the surfaces, okay, if you polish the surfaces to some extent, then friction will be reduced. See the benches in your classroom. The benches are polished. See the glasses, almost they are polished. See the board, this is also polished moderately. If it is polished heavily, if the windows and doors of your home, if the doors are polished moderately, then friction is reduced to some extent. Means if you touch the door, you will feel some smooth. If it is heavily polished, if it is heavily polished, if you touch, this hand never come. What is increases indirectly? Force of attraction between that paint molecules and your hand increases. What is that force actually? Force between same kind of molecules or force between different kind of molecules? I think you know the two forces.
Different kind of.
Force of attraction between different kind of molecules, we can call it as what? Adhesive force.
Yes, sir.
Force of attraction between different kind of molecules, call it as adhesive force. And force of attraction between same kind of molecules, yeah, same kind of molecules called as cohesive force. Yeah, I hope you know these basic things. Cohesive forces, non-cohesive, nothing but adhesive forces. Cohesive forces means force of attraction between same kind of molecules. And adhesive force means force of attraction between different kind of molecules. Okay, and see, if the surfaces are polished moderately, then friction is reduced to some extent. Keep in mind, very simple, nothing this is. If the surfaces are polished moderately, then friction is reduced to some extent. If it is heavily polished, then friction is increases. Instead of decreasing, the friction is increasing. Okay. And one more method also will help in reducing the friction. Let us see what is that. Another one is very simple, lubricant, oils, lubricants. Lubricants nothing but oils, grease. Okay. So if you use grease in between the two surfaces which are in contact, then friction will be decreases to some extent again. So lubricant is a substance. Lubricant is a substance which is used to reduce the friction in between two surfaces which are in contact. Okay. So what is the lubricant? It is some material, oil. It is behaves like some thin layer, polythene cover in between the two surfaces. So lubricant is a substance used to reduce the friction in between two surfaces which are in contact. Okay, and one more is very simple. We can write ball bearings. Ball bearings. Ball bearings. Just you observe the free wheels of cycle and vehicle. The wheels of vehicle at the midpoint, some small wheel is there, and having some spherical balls. Okay, with some grease, of course, is there, and the spherical balls will reduces the friction. Of course, that is actually rolling motion that will come. So the free wheels of vehicle provided with some ball bearings. The free wheels of vehicles provided with some spherical balls, provided with ball bearings to reduce the friction. Okay, because of the ball bearings, the friction is reduced to some extent. Okay, the free wheels of vehicles are provided with ball bearings to reduce the friction. And one more is streamlining. 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 So there will be a streamlined flow that will come in some other chapters like the mechanical properties of fluid. Here I used a streamlining, that's it. See, observe the automobiles and aeroplanes and some buses and all the things. Different vehicles have different construction, different shape. Bus like a rectangle, car some other shape. Aeroplane you observe it. It is like a bird in shape, like a bird. See, automobiles and aeroplanes have some special construction to reduce friction due to air. Okay, because they have some special construction to reduce the friction due to air. Okay, there will be some airflow opposite to the aeroplane. Okay, there will be airflow below the wing, above the wing. So these will we are going to study in aerodynamic lift in mechanical properties of some fluid concept. Some dynamic lift concept is there. We will learn there. Right now, streamlining means automobiles and aeroplanes are a special design. They have special design, they have some special construction to reduce friction due to air. Okay, see, nothing so far, nothing is covered. Just I started the very basic knowledge of friction. Okay, because I don't know whether you know all these basics or not. That's why I started with very basic, very convenient. I started with the meaning of contact force, started with normal reaction, and what is the next one? Frictional force, and I told you the meaning of friction. And later on, few advantages, general things, few advantages, and very few disadvantages, and some methods to reduce the friction. Now let us discuss what are the different types of frictions. Okay.
Sir, how heavy polishing will increase the friction?
Which one?
Sir, how heavy polishing will increase the friction?
Yeah, how heavy polish will increase the friction means very simple. Just you take one cardboard, you polish moderately. You polish moderately. Then you place your hand on a cardboard after some time. Then you are going to feel some smooth or not. Okay,
Yes.
just you polish your cardboard with a moderate little bit, like a door, like a door. Next time you do the heavy polish. Heavy polish. Okay, that means what? In between the molecules of the same kind, means in between the oil. Okay, you are doing some paint. Okay, you are taking some paint. So number of molecules in paint is what? Increases or decreases? If you heavily polish, number of molecules in the paint are increases or decreases?
Decreases.
Increase.
Increases or decreases?
Increase.
Because you are
Increases.
taking more paint, more molecules, more attraction. Increase. Just you place the hand on that. You feel it. You place the hand on that. Then here cohesive force is dominating inside the paint, and you are placing one more different kind of molecules on that. Earlier you polished moderately so that you felt that smooth. Now later on, it is what? Cohesive forces in the same kind of molecules is increases. Once you place the hand in that, then what happened? What is dominating actually? Force of attraction between different kind of molecules are dominating. Here cohesive force is dominating automatically.
Attraction takes place.
yeah, adhesive force also dominating, so attraction is increases. That's why, see, general thing this is, just you see the paint of a door. If it is polished moderately, you feel that smooth. If it is heavily polished, just you place a hand on that, how you are feeling. How you are feeling. Think in a positive way. If you think in a negative way, the physics is completely different. Think in a positive way. Will you feel that something is in, see, this is polished moderately. I felt smooth. If it is heavily polished, I am able to write it on the board. Is it possible for me to write it on the board? Heavily polished. It's not easy. Okay, means what? Frictional force is generally increasing. If the surfaces are moderately polished, frictional forces decreases. If it is heavily polished because of interlocking forces, molecular, because of the force of attraction between the molecules, frictional force will rises. Okay, so this is a general thing. See, here the best example is board. How is this board is light, moderately polished or heavily polished?
Moderate.
Moderate. Anyone will polish more. No, generally,
We lose the grip on the board while writing.
yeah,
So we'll lose the grip on the board
yeah,
while writing.
yeah. Okay, maybe you may lose the grip. Otherwise, maybe this top piece will attack the board because of the more polish. Okay, after touching after some time. Okay. Now let us see what are the different kinds of frictions. See, there are three different types of frictional forces. Okay, write down different types of frictions. Again, also basic. See, there are three different types of frictions. One is static friction. We can represent with Fs. What is static friction? We can represent with Fs. Another one, kinetic friction, or we can call it as a dynamic friction. We can represent with Fk. Other one is rolling friction. We can write as Fr. Let us see the basic meanings of these frictional forces. How many types of frictional forces? One is the static friction, other one is kinetic friction, other one is rolling friction. See, if I place any block on a horizontal floor, then if I applied a force like this, will the block will move? That we cannot say actually. That is based on the amount of force based on the given mass actually. See, here this body is rest on this body. What is there in between them? Some frictional force will be there or not? Yes, there will be some frictional force. So the frictional force present when one body rests over the surface of another body, call it as static friction, static rest. Static nothing but rest. So the frictional force present when one body rests on another body, we can call it as static friction. Okay, so this is the static frictional force because this body rests on another surface. Okay, for suppose if this body is moving with certain speed, this body is moving with certain speed based on the application of force. Then if the body is moving with certain speed also, there will be a frictional force in between the two surfaces. That means what? The frictional force present when one body moves over the surface of another body, we can call it as kinetic or dynamic friction. Dynamic means what? Motion. Dynamics, dynamy, some numbers are there. So motion. So the frictional force present when one body moves over the surface of another body, call it as what? Kinetic or dynamic friction. See the simple words. If the body rests on other surface, there will be a static friction. If one body moves over the surface of another body, then there will be a kinetic friction. Tell me how to get the rolling friction. Very simple. The frictional force present when a one body rolls over the cylinder, you take it now. Cylinder, the frictional force present when one body rolls over the surface of another body, we can call it as a rolling friction. So that friction is nothing but rolling friction. And see, every frictional force have some properties. They have some laws. Okay, this is nothing but frictional force present when one body rests over the surface of another body. This is the frictional force present when one body moves over the surface of another body. And this one, when one body rolls over the surface of another body. Okay, so basic things, nothing. Okay, nothing standard thing today. Okay, and see, every frictional force have some properties. They have some laws. Okay, laws of friction. And before this, let me discuss some other things. For suppose the applied force is increases. Okay, later I'll come to the laws. Before that, just you see. For suppose I applied something force so that the body does not move on a floor. So that this body does not move on a floor, let us suppose. Then what type of frictional force is existing in between these two surfaces? It does
Static
not
force.
static.
Static.
If I increase the applied force, then what about the static
Kinetic friction.
friction or not? If I increase the applied force, static frictional force also increases. Yeah, it will increases generally. Okay, no doubt that static frictional force is opposite to the motion. Static frictional force on body is backward, on floor forward. But generally we can represent like this. This is what? This is the static frictional force. Tell me, on floor on a body. It is
On a body.
on a body. For example, you are walking on a floor. Okay, if you are walking on a floor, frictional force on you backward. Frictional force on you backward. Frictional force on floor forward. Because of this, you are walking. Because of the friction is the reason to walk on a floor. Friction is the reason. If there is no friction, you can't walk. So, because I told you, it is a contact force. Frictional force is a contact force. Normal reaction force also.
Contact force.
Contact. What I started with this friction, just I started a word called it as contact force. Actually, I have to start with electromagnetic force. That is not good. So, contact force in first PU level, it is good actually. Frictional force is a contact force. And you know, contact force is a action and reaction force. It is a pair of forces. Tell me, will the pair of forces will act on the same body? No.
No,
Definitely they will act on different body. One is on person. What about the other one? If I draw this also on person. Okay, this is on where? On floor. If this is the action, this is the reaction. If any one is the action, other one is the reaction. And because of this frictional force, the person is moving. For suppose, a vehicle is accelerating. This is also a simple question actually. So, vehicle is accelerating. A cycle is accelerating like this. Are you able to see here?
Yes, sir.
Cycle, yeah, cycle is accelerating like this. Cycle is accelerating. This is accelerating. Now, if the cycle is accelerating, now there are two types. Okay, there will be a frictional force in between the two types. Let us see the direction of the frictional force on the two types. So, if the cycle is moving on a floor with an acceleration A, then frictional force on a front tire, no doubt, it is backward. Frictional force. See, if this frictional force on a tire is forward, for suppose if the frictional force on a tire is forward, and where is the frictional force on floor? If I draw this as right, and this will act on what? Where?
Ground.
Ground. Okay. So ground. Here right now, see, frictional force on front tire is what?
Backward.
On ground. On ground. So this is the reason to move the body here. This is the reason. See the same concept. So because of this frictional force, the cycle is accelerating. If it is decelerating, opposite. If the, I think you know the meaning of acceleration, deceleration, retardation. If it is accelerating, see, if you are running, frictional force on floor is in which direction? Forward. Cycle also running, cycle also moving. Then frictional force on floor is forward, on front tire is, on tire is
backward.
and see, on back tire will slide. Back tire will slide. Actually, that will slide because of the torque. Actually, generally, you know, force in laws of motion. That is the reason. Force is the reason to set the body into the motion. Of course, we can stop the body. We can stop the motion of object also by using the force. Force is the reason for a linear motion. Here the tire, it's not linear actually. It is some circular motion right now. So that also will come in the next chapters. And for circular or for rotatory motion, we use another word, call it as a torque. If you enter into the hall or if you enter into the classroom, you are going to apply a force at the edge of the door or at the hinge of the door. At the hinge of the door, where you are going to apply the force when you enter into the classroom? At the edge of the door or not? Is the door will move along a straight line?
Circular
How
motion.
the door will?
Yes.
Yeah, door will actually
Circular
rotate.
motion.
About that hinge, the door set into rotation. So that force and that distance we can call it as one more quantity, torque. Actually, because of the torque, due to the torque, the frictional force on back tire is forward and on floor is backward. See, this is the direction of the frictional force. On back tire is forward, on floor is backward. If the car is decelerating, if the vehicle is decelerating, then front tire frictional force is backward, back tire also frictional force backward. So both frictional forces are backward means what? Both frictional forces backward means after traveling some distance, the car or the vehicle comes to rest or not, because both are acting in same direction. This is the case when vehicle is accelerating. See, on front tire, back tire, front. Okay, so this is because of sliding motion actually. If it is decelerating, these two frictional forces will act backward. If both frictional forces act backward, then after traveling some distance, this vehicle will comes to rest. Okay. So anyhow, we will see exact direction when I use the block over the block. Actually, that is the good concept in friction. Remaining all are nothing. Okay, we can apply a force by inclined, by something angle theta, by horizontal, by inclined plane. We can apply the forces. One more is there, block on block concept. There I am going to show you in what direction the frictional force will act exactly. Right now, if the vehicle is accelerating, frictional force on front tire is back tire is front. Back tire because of the torque you wait for a rotatory motion chapter. And see, here I applied a force of something 5 Newton. What about the frictional force? For example, you are sitting in a chair, in a bench. I am trying to pull you up. Whenever you are sitting in the chair, what is the frictional force in between you and your floor? Static or not? Static. Okay, static. If I try to pull up, then I am increasing my applied force. What about you? You are also trying to increase your frictional force or not? Starting. You have some opposition, okay, resistance, everything. Frictional, nothing but resistance actually. If I try to pull up, you won't come first. That means what? Frictional force increases. If applied force is increases, what about the frictional force? Frictional force also increases. And if I try to pull little more up with a huge force, 5 Newton becomes something 10 Newtons. Maybe you also changes to 5 Newton becomes 10 Newtons. Okay, you have a last capacity 10 Newtons. Last. Okay. If I use something 11, then what happened? No doubt you are going to move because of my applied force. Then your static frictional force will be converted into what? If I pull up like this,
Kinetic friction.
Kinetic friction.
But you have some maximum value of static friction. How much the maximum value? Just now I've given number 10.
10.
You have a maximum value of static friction. That's something 10, for example. The maximum value of static friction, we can call it as limiting friction. So keep in mind, the maximum value of static friction, we can call it as limiting friction. Or suppose if I pull this block in this direction, Here frictional force increases, and this reaches the saturation. This reaches the maximum value. The maximum value of static friction, we can call it as limiting friction. So that can be represented as FL. Note down, this is also a static friction. And static friction is the self-adjusting friction. Means if you apply something 10 Newton, how much the static friction developed in between them? 10.
10.
That is based on this mass. If it is 11, answer is 11. Okay, answer is 11. Okay, that is also based conditions applied based on the given mass. Don't worry, I will give you problems also. So frictional force proportional to applied force. If you draw a graph, the graph is looks like this. Let us suppose applied force, let me take on x-axis, frictional force on y-axis. If the applied force is increases, frictional force also increases. Applied force is increases, frictional force also increases and reaches the maximum value. After reaching the maximum value, if I apply the force, then what about you? So you have a maximum value of saturation. The maximum value of this static friction, call it as
Limiting
FL,
friction.
limiting friction. After the limiting friction, you are coming with me. If I applied a force, then what happened? Your static friction is reaches to maximum value and converted into kinetic friction. Means kinetic friction will be decreased or not? Kinetic friction will be decreases like this. So you are going to see the graph like this. Little decreases. Then body moves with some constant speed. So static friction is converted into kinetic friction. Actually, this is possible. This is an experimental observation. Okay, this graph is nothing but one of the observations from the experiment. For example, you know, in previous chapters, like a block is placed on a horizontal surface, one more is suspended vertically, so that the wire is passed over a frictionless pulley. And here something friction is there. If this mass is equal, these are equal, then this body ready to move. The body is ready to move. If this is little increases, okay, based on this friction also, this is also means conditions apply everywhere. So if the weights are increases here, then what about this one? For a particular amount of weights, this is increases. So indirectly, what is increases here? Frictional force is increases and reaches to maximum value. After for a particular load, it will move with what? Some constant speed. That means
Kinetic friction.
static friction is converting into
Kinetic friction.
Kinetic friction.
This is the graph. Okay, basic graph. This is. And see, every frictional force have some laws. Static friction, kinetic friction, rolling friction. All the frictional forces have some properties. And each and every frictional force proportional to each and every static, kinetic, rolling, everyone. Each and every frictional force proportional to normal reaction force. Static frictional force proportional to normal, kinetic also, rolling also. Now I am using the F. Okay, instead of writing 3 times, just let me write only 1 time. Okay, and static friction is a self-adjusting force. Okay, so F proportional to N, let me write F is equal to mu N. F is equal to mu N. So mu we can write it as F by N, where this mu is called as coefficient of friction. What is this mu? Coefficient of friction. It is the ratio of frictional force to the normal reaction. If it is a static friction, we can write Fs is equal to mu Sn. If it is a kinetic, mu Kn. If it is a rolling, mu Rn. Okay, next I want to use all these things and I'll do some applications also. Okay, maybe in the next session, applications with a small problems I am going to start. Right now, nothing is covered today. Just the introduction and basic concepts are covered. Nothing. Just advantages. These are by reading only we can understand actually. So Fs is equal to mu Sn, Fk is equal to mu Kn, Fr is equal to mu Rn. And no doubt, Fs greater than Fk greater than Fr. In the same manner, we can write mu S greater than mu K greater than mu R. Okay. So the coefficient of friction mu, it may be, it is a number. See, it is a number. It is the ratio of frictional force to the normal reaction. Normal reaction also the force. Normal reaction also a force. Force by force, Newton cancel. So what is coefficient of friction? It is the ratio of frictional force to the normal reaction. Nothing but it does not have any units and dimensions. Okay, coefficient of friction is a constant. Okay, so these are the basic things covered today. Okay, in the next session we will see some formulas and applications. Along with the applications, I'm going to cover problems also. Okay, my target is to cover the basic things. Next, I will move on to the concepts. So many variety of concepts, and after covering the concepts, let me solve some problems. Okay, after covering the concepts, no doubt you are going to enjoy problems from any type of book. Okay, right now let me stop today. Thank you.
Thank you, sir. Bye, sir.
Thank you, sir.
Thank you, sir. Bye, sir.
Yes, sir.